AI tools are becoming easier to use. At the same time, the people who design them may be gaining more influence than ever. On the surface, automation looks like it empowers everyone. A marketing team can generate campaigns in minutes. A small startup can build software with AI assistance. A hospital can deploy diagnostic tools without building them from scratch. But behind these systems are design choices, model architectures, training data, default settings, optimization goals. And those choices are not made by most users. As AI spreads, a new divide may be emerging between those who use the systems and those who shape how the systems behave. Consider a company adopting an AI-powered hiring tool. Recruiters log in, upload resumes, and receive ranked candidates. The interface is simple, the workflow feels efficient, but the criteria that determine ranking, what counts as relevant experience, how gaps are weighted, which patterns signal potential, are embedded upstream. They are defined by system designers and configured by administrators. The recruiter uses the system. The designer shapes the logic. That distinction matters. This divide is visible across industries. In finance, risk models assess creditworthiness using complex combinations of variables. Loan officers interact with outputs, but the structure of the model determines which factors matter most. In logistics, route optimization tools decide how goods move across regions. Managers oversee the process, but they rarely modify the core optimization algorithm. In content platforms, recommendation systems determine visibility. Creators and viewers participate, but designers define engagement signals and ranking logic. The user operates within boundaries that someone else configured. At first, this seems normal. Most technologies are built by specialists and used by others. Not everyone understands how a database works before using a website. But AI systems influence decision-making itself. They do not just process data, they structure choices, prioritize options, and suggest actions. When design choices affect outcomes at scale, influence shifts toward those who define those parameters. There is a credible counterargument. AI tools can democratize access to advanced capabilities. A small business can now access forecasting models once reserved for large corporations. An individual developer can build applications using pre-trained systems without needing deep expertise. From this perspective, automation reduces barriers rather than creating new divides. That is partly true. Access is broadened. But access to use is different from access to control. The distinction becomes clear when considering configuration. Some organizations rely entirely on default settings provided by vendors. Others invest in customizing models, adjusting objectives, and fine-tuning behavior. The latter group exerts more influence over how automation shapes outcomes. As AI becomes central to operations, the ability to configure systems becomes a strategic advantage. Not everyone develops that capability. This shift can also affect internal power dynamics. Within companies, teams responsible for data science, model tuning, and system integration may gain influence. Decision makers may defer to technical teams when interpreting outputs or adjusting parameters. Those who understand how the system works and how to modify it hold a different kind of leverage than those who simply operate it. The divide is not only between firms, but within them. There are longer-term implications as well. If a small number of firms provide foundational AI infrastructure, large language models, cloud-based analytics platforms, optimization engines, then many industries depend on external design decisions. Updates to models, changes in pricing, or shifts in policy can ripple outward. Users adapt, designers steer. Over time, strategic direction may be shaped less by frontline actors and more by those who define system architecture. However, this outcome is not inevitable. Organizations can build internal expertise. Open source tools can distribute design capabilities more broadly. Regulatory frameworks can require transparency about how systems operate. The divide between users and designers can be narrowed through education and institutional investment, but narrowing it requires deliberate effort. There is also a psychological dimension. When users treat AI systems as neutral utilities, they may overlook embedded assumptions. The tool appears objective. The interface feels straightforward. Yet every system reflects choices, about data inclusion, optimization goals, and acceptable trade-offs. If users lack visibility into those choices, influence remains concentrated upstream. Understanding becomes asymmetrical. This does not mean that AI designers wield unchecked power. Markets, competition, and regulation constrain system builders. Users can switch platforms, demand transparency, or build alternatives. Still, as automation becomes infrastructure, the capacity to shape its behavior becomes increasingly significant. Using a tool and shaping a tool are not the same role. As AI continues to integrate into everyday decisions, the most important question may not be who has access to automation. It may be who defines how automation works. Because in complex systems, power often lies not in operating within rules, but in setting them. Recognizing this new divide does not require rejecting AI tools. It requires awareness of where influence concentrates and whether that concentration aligns with broader institutional goals. The spread of automation can expand capability. Whether it also redistributes control depends on who participates in designing the systems that increasingly shape our choices.